Good evening, everyone, and thank you for showing up at this hour. I have quite an incentive to finish up early tonight because I have to drive back to the Washington, D.C. area for another meeting in the morning. And I guess my number one problem is, how do I keep awake? If we can have the first slide, please. Well, two-way radio is really affecting our lives today in more ways than many people imagine. This conference is termed, wireless communications, and of course here's one of the early forms of wireless, and the Mark II version, and the Mark III version. Back in the 20s, when radio broadcasting was coming about, radio programming was limited to maybe afternoon and early evening hours. And as a youngster, I remember my father putting the earphones in the fruit glass on the table, a bowl rather, and there was one night a week, I think it was Thursday nights, when the broadcast stations went off the air early, so you could get a chance to listen to some real distance, like over the Atlantic and that sort of thing. And then you would send your reports into the newspaper and see your name in print the next week. But in the 20s, there were two department stores on the East Coast, one in New York, one in Philadelphia, owned by the John Wanamaker Company. And they each had a broadcast station. And during the non-programming hours, they would talk to each other into a receiver that looked something like this, and exchange information on warehouse transfers. If you got your order in for the green icebox like before 11 o'clock, they could deliver it from Philadelphia to New York the same day, and that sort of thing. And that was a very early version of point-to-point business radio service, back when radio rules were very relaxed. Public safety were one of the first ones to actively use radio for the dispatchers to talk to the vehicles. And here is what an early police radio transmitter looked like. It was really a modified broadcast transmitter in the 50 to 100 watt category. And these stations operated just above the broadcast band. And here are some typical mobile installations of that day. The vertical antenna. And you had to be careful how you took the corners with this rig on a windy day. Detroit was credited as being the first ones to have a licensed radio system in full operation. This was a one-way. It was a very early form of paging. The dispatcher would call a police car, and the first thing a policeman would do is look for a telephone on the pole, police phone, and call back and say, "Got your message." And in honor of the city of Detroit, for their pioneering work, one of the first milestone awards of IEEE, milestones in history, went to the city of Detroit for their activation of a regular one-way radio communications. And this goes back, I think this started on April the 7th, 1928. And this is what a log looked like back in the 20s. You're actually too far away to read this now, but most of these frequencies on here were just above the broadcast band. As a matter of fact, even in the 1950s, you could tune to the high end of a regular AM radio and hear New York City Fire Department still using some of the old frequencies for one-way dispatching, and some of those units were modified for two-way, and we'll talk about that a little bit later. Back in those days, vacuum tubes replaced transistors, or the other way around, and these required moderately high voltage for the plate supply. This is what was called a B battery, and this consisted of 30 1.5 volt flashlight batteries molded in a case which had a cardboard wraparound, and it was tapped in the center for 22.5 volts. But it usually took 4 or 5 of these batteries to get up to 180 to 225 volts for the high voltage supply, both for automobile radios as well as for house radios. Of course, the house radios didn't present quite the same problem, since you could build what's called a power pack and eventually those radios became AC operated, as the saying went. But the B batteries in the car were quite a problem, and it was not most of the time the B batteries were in a steel box under the running boards, and it wasn't unusual to see a car going down the street with the box rusted out and the batteries dragging on the road. So a fellow by the name of Bill Lear invented the vibrator to solve that problem and to get rid of the bulky and expensive batteries. Very often when I come to a college campus and mention the word vibrator, I get all kinds of snickers from the audience, but you're very quiet tonight. This vibrator had a set of contacts which interrupted the primary of a transformer, created pulsating DC, and of course coming out of the secondary became out AC, alternating current, was rectified and then filtered. And here are some early version radios. You can see here is a mobile receiver and a vibrator power pack that mounts on the firewall. And here is the same receiver with an AC power supply that could be used in a precinct police station so that all the precincts could hear what the dispatcher messages were being sent. Of course, two-way radio was far from ideal for police work, and so the city of Bayonne, New Jersey was one of the first cities to go two-way, where the police officer in the vehicle could pick up a microphone and answer back to the dispatcher. And incidentally, the federal regulators back then took such a long time to come up with special temporary authority to test the system that the fellow who was trying to sell this system, partly by the name of Frank Gunther, went on the amateur bands, on the 5-meter amateur band to put the demonstration on, and nobody was the wiser. And so the second IEEE two-way radio Milestones in History Award went to the city of Bayonne, New Jersey, and this date you can see 1933. And here are the ceremonies at Bayonne, New Jersey, and the fellow in the center is Frank Gunther, who got the first developmental contract, and the fellow on your left, came along and got the job by being a low-price bidder, and his name is Fred Link, and yours truly is on the right-hand side. And here's what a typical mobile installation looked like in the trunk of a car. Incidentally, these were in the frequency range of between 30 and 40 megahertz back then, when the two-way radio came to be used. Here is a typical police transmitter in the mid to the late 30s, and this used for those of you who are hams, a 6L6 tri-TED oscillator, and the plate current of this tube was only exceeded by the crystal current. And once again, for those of you, with an amateur background, 807 the final with Class B modulation. You know, Class B modulation is the kind where the plate current swings all over the place. And there used to be a song back then which QST magazine claimed was written for amateur radio. And the name of that song went something like, "It don't mean a thing if it ain't got that swing." Here's a typical AM 100-watt police transmitter. And about this time, those of us who were in amateur radio were seeing the TZ40 tubes. A pair of TZ40s in the final modulated by a pair of TZ40s. And I have one of these cabinets home right now in my basement. I've stripped the radio frequency part out, and it's my tool case and rack and so forth. And in fact, 2 weeks ago I just put a fluorescent lamp inside of it so I can see what I'm doing in the dark. There was quite an argument developing into the end of the 40 decade about whether Major Armstrong's new frequency modulation technique was the way to go, because one of the things that plagued mobile installations, not only entertainment but as well as police vehicles, was the noise generated by the spark plug firing. And the old Fords of that era were noted, they seemed to have twice the distance of being able to cause interference than say General Motors cars. Anyway, the state of Connecticut gave a contract to the Link Radio Corporation to run tests on AM versus FM and FM won out. And this third milestones in electronic communications was given to the state of Connecticut, and this plaque is now at the communications headquarters building in Hartford. There's a renewed interest in these milestone programs at IEEE, and I'm now working on getting credit for the first mobile relay system in Contra Costa County, California. And a fellow named George Burton was able to convince the local politicians to put up some money for, here we have a license for this system, which goes back to the early 30s, around mid-30s. And this system was on the air up and through, I guess, a good part of World War II. And it was a system that originally used the frequencies just above the broadcast band to talk out to the cars, and the cars talked back between the 30 and 40 megahertz band. And here is what the adapter looked like. This panel right here was the interface between the receiver and the transmitter in the cabinet. And here's a schematic of this very complicated mobile relay adapter. Of course, back in those days, in a normal two-way installation, there was one box for the transmitter and one for the receiver. And by the end of World War II, here is a typical installation, a dynamotor-powered unit, could be upwards of 75 watts, and a receiver with a vibrator power supply built in by this time now. Learn how to get rid of the hash from the vibrator and put the whole assembly inside the receiver cabinet. And here, that previous slide was link radio. Here's the Motorola units look like after World War II. And back in those days, we had a problem with police use, especially with a 75-watt unit, because police cruisers like to do that cruise and drive very slow when they're in a downtown business district patrolling the area. And one of the problems was keeping the batteries charged, especially if it was a rainy night and the headlights were on, the windshield wipers were going and everything else. And so Leaf Neville came up with an alternator, back in the early 40s, that had a relatively high charging and fairly constant charging rate. The only problem was you had to set the idle speed up fast enough, otherwise when you press the microphone button, the engine would stall. And here's a General Electric unit of the two-unit era. Another one. Radio Engineering Laboratories in Long Island City took the receiver and transmitter and put it all on one chassis. These round things you see on here are called dynamotors. And for some of you younger solid-state kids, that's a motor and a generator all in one assembly. And one unit would run at half speed to supply the receiver voltage, and then go up to full speed when you transmit, and then the second dynamotor would supply the additional power that could generate between 25 and 50 watts of output. And back in that era, these are the two parts of a very, very well-calibrated watt meter, a connector and a light bulb. And so help me God, Motorola's instruction manuals right after World War II had drawings to show you how to very carefully remove the base from a light bulb and how to put some spaghetti over the bare leads and solder it to that coax connector. Here is a 250-watt police type of transmitter at the end of World War II. Once again, those with an amateur background, an exciter with a pair of 807s driving an iMac 250TH or TL on the final stage. I was mentioning to somebody tonight at dinner at the table that when I was a youngster in amateur radio, I was always impressed by the ads from the West Coast from a company called IMAC, E-I-M-A-C. And they had a push-pull final amplifier on the front cover of one issue, and underneath it said, a pair of 100THs or whatever it was, one pushy, one pulley, working like heli. This is a 3,000-watt transmitter, more for statewide use, and had a pair of I guess 4-1000s in the final or something like that. This was a driven grid rig and tetrodes, and the exciter here, and the final stages here. Both of these cabinets had 2 receivers in them. Normally one receiver would be used for the normal push to talk, talk back and forth activity, and the second receiver could be used in installations where they did not want the cars to talk to each other, so they'd use one frequency to talk out, another frequency to talk back. Or that second receiver could be used for mutual aid, where a police department might be capable of switching the frequency to transmit and talking to the sheriff, or to the next town, or to the county, or to the state. And this is a 746 watt mobile installation, 1 horsepower. And this is what Link Radio used during the war years. Two-way radio had a very unique status during World War II, because everybody was getting civil defense minded, and it was fairly easy to get a defense order rating, so the towns could buy police two-way radio equipment, and it could be produced during the war years as a vital product for the good of the country. And this was actually used between the warehouse and the production plant downtown, which were about 2 miles apart. The only problem was if you put that same Leeson-Bell alternator on this, probably a horse couldn't pull it. And so when you first went to Link Radio, you got indoctrinated by changing a storage battery in that thing about 2 or 3 times a day. And you soon learned to keep your tie in, otherwise when it rested on the damp sulfuric acid on the top of the battery, your tie would be full of holes the next day. At the end of World War II, the land mobile industry had its first encounter with the television industry. The first television receivers that came out after World War II had a Channel 1, but there never really were any Channel 1 stations on the air, and of course Channel 1 disappeared from the tuners. And the reason for that is that the allocations were made during World War II rather, and by the time the war was over, the demands for communications were beginning to made themselves known, and so the FCC did a quick reshuffle of part of the spectrum they did several things. They moved the FM entertainment band from the 42 to 50 megahertz, or 42 to 44, I think, up to 88 to 108. They shuffled around the 5-meter amateur band to 6 meters. They broadened the land mobile band from 30 to 40 megahertz to about 30 to 50, and eliminated Channel 1. And that's why you never could find the Channel 1 on the air. Now, something else also happened at the end of World War II. The FCC authorized what we call high band, back then 152 to 162 megahertz, and now it goes from 150 to 174. But we had a little trouble selling this at that time, because the old policeman said, there's no way you're going to get any range with an 18-whip antenna like that. But they were proven wrong, and the high band became very, very effective. This is what the base station looked like. And you must realize at this time now we had television was starting to become very popular. And so we no longer could have the open construction, and you can see the shielding here around the final amplifier to minimize spurious radiations. When the commission authorized the 150 to 160 megahertz band, it did several things. It created the common carrier services. There were 2 kinds of common carriers. One was a wireline providing a radio service, and back around 1947, 1948, we had some people with telephones in their car who could talk to any landline number over quite a wide area. They also, they being the commission, authorized the miscellaneous common carriers, which was a service that was normally operated by a telephone answering service and provided message handling. Back then it was illegal to tie into the public switch telephone network unless you were a common carrier. And this is a typical telephone answering service providing radio dispatch. This is the link radio attempt at a one-piece unit, which, as you can see, fits right in over the hump of the transmission area. And here's a little control head here. And other people, followed and did the same thing. A fellow by the name of Ramsey McDonald, operating out of a small garage in Richmond, Indiana, put a whole bunch of relays in a rack, external, and devised what he called was a system called dial direct. And with the use of stepping relays and telephone dials, you could then dial numbers from a vehicle, or the vehicle could be dialed, and this could also be non-operated assist. And we're talking like the mid to the late 40s, well, late 40s now. As we got away from World War II and the U.S. production kept building up, other people started to get in the act. The only people in two-way radio business about this time was Link Radio, Motorola, RCA, and GE. Federal made one of their early attempts to get into the two-way radio business. And I might mention that one of the other things the FCC did at the end of World War II was to create the taxi cab radio service. Before this time, you had to practically either be a police or a fire activity or something like that to get a two-way license. And the taxi cab radio service became very popular. The New York Times had a story on the front page about one woman's experience with taxi cab radio. She called the taxi cab outfit for a cab, and the cab pulled up right in front of the house. Within about 45 seconds, rang the bell, and she said, "What do you want?" He says, your cab lady." He said, "I'm not going with you. You drive too fast." Philco also was in the act for a short period of time, and we jokingly say that their shipments were only exceeded by their returns. Belmont was in the act, and they had a rather crude unit which could either be operated as a mobile unit or as a base station. This was the base station adapter here. Telephone lines were at that time used to control the base stations by putting a DC voltage on the line to key the transmitter and superimposing that over the voice. There were a fair amount of low band units, rather very low frequency police talk-out transmitters still in use as we went even into the 50s, and sometimes these continued for some years later by allowing the base station to talk out just above the broadcast band, but the mobile units to talk back in the 30 to 40 megahertz band. And here's a North Carolina installation. This is the 1500 to 2500 kilohertz receiver and the 30 to 40 megahertz FM transmitter. So it's a hybrid system, AM in one direction, FM in the other. Then, as we got into the 50s, the Federal Communications Commission created the Business Radio Service, which turned out to be the fastest growing service. All you had to do was be in a legitimate business, which varies state by state. But a small outfit in Raleigh, North Carolina, operating under the name of Aeronautical Electronics, and had a product name of Aerotron, came out, they operated out of the Raleigh-Durham Airport, one of the hangars, and they had a small AM 100 to 120 megahertz unit that was used for very small airports on what was called the Unicom channel. And Charlie Browning reinvented the unit by making it FM, moving it up to 150 megahertz. And one of the big features of this unit is that it was a universal power supply unit. It could be used on AC as a base station or DC as a mobile, and back then they received and transmitted on the same frequency, so you could interchange the units. If your base station went off the air at nights or weekends, you just take a unit out of a mobile and get back on the air without paying overtime rates. And also the power supply was very universal. We're getting now into the mid-50s. It's that time in our life when the automobile system went from 6 volts to 12 volts. So this power supply was 6 volts negative ground, 6 volts positive ground, 12 volts negative ground, 12 volts positive ground, or 117 volts AC, depending upon what cable harness you plugged into the back. Now you may wonder, why do we have negative and positive ground systems? Well, in the physical and mechanical design of early automobiles, a certain amount of the headlight ground current went through the radiator. It wasn't meant to be that way, but it worked out that way. And the problem was, with some cars, it was worse than others, and some designs. And the result was electrolysis took place and clogged the radiators. So some companies cured the problem very simply by using a reverse ground system. And of course, when they built cars in later years, that problem disappeared. And so we're pretty much standardized on negative ground today. That same unit was also redesigned to a 12-channel unit with a bank of crystals and rotary selector switch for the 150 megahertz marine frequencies, which the FCC authorized and eventually displaced the small craft from operating down the 2 megahertz band. And it was also later copied by Hammerlin. Same basic design, fully universal power supply. And the idea was a suede shoe salesman would come in with 2 units, one in each hand. He'd put one in the secretary's desk with a short whip antenna, take the second unit out in the boss's car with a rain gutter antenna clipped on, and plug it into a cigarette lighter, and take the fellow around the block and say, you see how loud and clear it is? Just think how much better it's going to be when we put the 100-foot tower up in your backyard. The idea was to close the sale on the first call. And that program was quite successful at GE, not too far from here now, they weren't then, wrote quite a complimentary article in their house organ paper, and went after the same business by coming out with this little radio, still using vacuum tubes, called the Pacer. And then Motorola got on the bandwagon and redesigned one of their motorcycle units and called it the Business Dispatcher, but some of the industry called it the Pacer Chaser. Around this era, we started to get interested in the handheld units. There's a portable, more like a lunchbox, with instant heating tubes for the transmitter. They're all tube type, no transistors. And here is one of the earlier motorcycle radios on the market. One metal saddle, at each side of the rear wheels. And the joke used to be that at the end of a tour of duty during the day, you'd take the unit apart and pick up all loose parts in the bottom tray. Link Radio took the receiver of one of those and put it in a wooden box, and that was a monitor receiver. This is during the era when there was a lot of interest in monitoring police calls. There's a famous joke in New York City where 2 wreckers collided on the way to the scene of an accident, trying to get there first because they both intercepted the same police call. Then, as time went on, the 150 megahertz band got loaded and the channels were split, and the FCC came out with an experimental assignment at 450 megahertz. One prominent radio manufacturer said that 450 would never work for land mobile, and I guess that company still gets kidded about that. So at this time, my wife was my laboratory assistant at Link Radio. So together we had a small job shop operation going in the engineering department, and we made 50 of these transverters. These took a 150 megahertz installation and converted it to 450 megahertz. There was a receiver adapter, let's see, a up converter here, down converter rather, and then a tripler and an amplifier for the transmitter, so you went at 150 and came out at 450. And we loaned 25 of these units to Detroit Checker Cab and 25 to Chicago Checker Cab. And they could check the high band versus UHF to see where they got the coverage, where the equipment performed. And it did very well. The project was so successful that we went into production. Here's a complete 450 megahertz unit. At Link Radio, we also made this unit for RCA. And then when Link Radio, when Fred Link sold out, we went over to Dumont. We made the same exact unit there, and Dumont also private labeled it for Bendix. In any event, we also made the front page of FM and TV radio communications. It was quite a unit for its time. The FCC, in coming up with a final frequency plan, separated the base and the mobile frequencies by 5 megahertz. And so what came about was the repeater, where the output of the receiver fed the transmitter, and a duplexer was used for a single antenna. And then by using different coded tone squelch frequencies, Group A could talk through the system, and Group B would not hear the calls that weren't intended for it, and Group B could talk, and Group A units wouldn't hear it. Now, they both couldn't talk at the same time, but after a while, there were certain gadgets came out, like lights and what have you, that would tell you the other party is using it, and it worked out quite well. And here you could have a common base station repeater, which could be shared, which got to be known as a community repeater. And that has another advantage, and that is that you could equip, take a mobile unit and AC power it with a fixed antenna, and you can talk through this mobile relay, and then you no longer had to lease telephone lines between the excellent antenna site location and the dispatcher's office. Even back then, we were having trouble with the telephone companies raising rates. They got wise to the fact that we were doing several things on one metallic pair. We had audio coming and going, and then when you wanted to transmit, we superimposed the DC voltage. So many telephone companies that went and filed tariffs for twice the rate because we were doing twice the function, even though they were only supplying one line. So, and then also there are certain market areas where you cross state lines. You know, the Cincinnati airport is not in Ohio, it's in Kentucky and that sort of thing. And so when you cross lines, you pay some very heavy rates even back then. So this type of operation eliminated telephone lines. Now, Detroit Checker Cab came back to us and said, gee, we like this system. We'd like to give you an order for 897 units. Well, 900 units is a lot of radios back then, and they were selling for about $1,000 a piece. The reason that Detroit Checker Cab wanted to go, because an outfit in Indianapolis called Monitor Radio had a tunable radio in the 150-160 band, which taxi cabs used to buy, and then they'd monitor the calls of Big Brother in the area and steal all the calls. So 450 megahertz provided an opportunity to beat that system. Well, there were 900 cabs, and we applied for a license, but the Friendly Candy Company only came back with 3 frequencies. Well, there's no way that you can dispatch 900 cabs on 3 channels on a rainy payday night in a city like Detroit. So since Link Radio really needed the business back then, you know, sometimes a necessity is a mother of an invention, we divided the city up for reuse. We weren't smart enough to call them cells, we called them zones. So really the first cellular system went on the air experimentally in 1949 in Detroit using manual handoff. And we had this map we had plasticized, and then it would clip on the sun visor of the cab, and it took the driver about 10 days of use to memorize the city, and he would just switch to the channel. And as you can see, you have zone 8 here, and you don't have zone 8 again somewhere else. Well, here's zone 7, zone 6, so you see this cluster is 6, 7, 8. You drop the 5 here, zone 1 is over here, and 2 is over here, and so there were 8 zones in here, but there were never any 2 frequencies side by side, which worked out quite well, except that we started getting complaints of cell jumping, where the signals would drop out and then show up again in another part of the city. So about this point in life, we were up to about 400 cabs installed, and we really needed the installation certificate signed. So one night at the bar at the Statler Hilton Hotel, a fellow named Jim Craig and myself were scratching our heads and saying, you know, what can we do to cure this problem? And then I finally said, you know, Jim, you're the antenna expert, and you're always telling me that ground plane antennas are lousy because of their relatively high angle of radiation. And we use ground planes to restrict the coverage so you wouldn't go too far. And so we decided amongst ourselves the thing to do really was take the ground plane and turn it upside down, and then you had an umbrella-like, you know, packed in coverage. And by this time it's getting close to midnight, it's raining lightly outside. And we went up to the roof of the Detroit Leyland Hotel, and Jim said, well, who's going to climb that sign to turn it upside down? I said, well, you know, since I outrank you, Jim, you better look in the mirror and you'll see who's going to climb up there. So he climbed up grudgingly, turned it upside down. We went back to the garage, signed out for a cab, drove it around the city. It worked. And at 8 o'clock the next morning, we were in Carl Anderson's office, and his first remark was, gee, for guys in deep trouble, you should have smiling faces. We say, Carl, all we ask is that you take a ride with us. And that cured the problem of high-angle radiation hitting certain objects and bouncing the signals back and forth. And by, I think, 10:30 that morning, we had a signed installation certificate for over 300 radios. And we got on an old Convair plane back then with a heavy tailwind. And I think by about 12:20, we were in Fred Link's office, and he didn't hear from us. We were too busy getting a paper signed. So before he could say too much, we just said, Fred, would you rather keep chewing us out, or would you rather have the signed certificate? Anyway, over the years, we dabble around the test equipment end of the thing. This is a frequency monitor. It consists of a bank of crystals, which you heterodyne with a whip antenna on here, and then you amplify the beat note, limit it, count it, and you get a direct reading on the meter here as to how far off frequency you are. The crystals are temperature aged. There's a thermometer in the knob, which went to a heat sink housing the crystals, and you would then apply a correction factor to the tuning knob here against the charts, and also you could measure frequency deviation as well, or the modulation. In the latter part of the 50s, many of our cities became rather affluent financially, and back in 1957, 58 there, I guess it is, the city of San Francisco had 200 police cars on the street, of only which 40 of them had two-way radio, and the rest were one-way. And the ones that had two-way radio had the AM talk out, the FM talk back. So the city decided to really go for it and go for a full two-way radio into elaborate system design. Here's what the dispatcher's console looked like. You know, it just grew as the demand for more telephone service, more radio service. And here are the two dispatcher boxes here. And a new console was put in with a conveyor belt system where the operators along here and the other side would take calls, put them on the appropriate coded IBM card. They would drop here, and then there were 4 dispatchers around here. There was one channel for marked cars, one channel for unmarked detective cars, another channel for the motorcycle squad, and a common 4th channel. Every police vehicle in the city had a common 2nd channel, so that if the police officer was in trouble and he had to get through to the dispatcher, he could override the system. If a dispatcher was giving out an APB, an all points bulletin, the mobile unit would switch to the emergency channel, and of course he would be heard in here, and he could override the whole thing. There's a status board. Each vehicle is a plastic plate with a vehicle number. There are 4 colored lights controlled by these switches, and there's a map of the precincts of the city, and the lead vehicle is also represented here. So the sergeant in charge of communications could look at that board, and at any instant in time he could tell, generally speaking, what shape the city was in. If it was a red light, that meant, you know, police on emergency assignment. I guess a white light meant out of service for personal reasons, meals, so forth. And a blue light is cruising, and a green light meant some other thing. In any event, it gave them a good indication of what was going on. And here you can see the city of San Francisco's map with the precincts. And back then we used to have a service called Conelrad. Every two-way radio system, even a little dinky taxi cab outfit had to have one of these receivers monitoring a local broadcast station, so that if there was a civil defense alert, the broadcast station would send a signal that would trip off this receiver. And finally that was all done away with, but back then it was a requirement. And one of the, this contract happened at the time when the city of San Francisco was being criticized for the salaries they were paying for such jobs as street cleaners and garbage collectors and so forth. So you can imagine what a radio technician was getting paid back then. And one of the terms of the contract was that you had to have an effective way of minimizing overtime pay on nights and weekends. And of course, one of the worst things can happen in the police system is the base station goes off the air. So we had 2 base station transmitters for each of the 3 basic channels. And every morning when the sergeant of communications came in, whatever transmitter was being used, he would switch to the other one. So if it didn't work, you found out that could be fixed during the daytime, during regular pay scale time. And that was the way of solving that problem. Also, a few years after that, the mobile radio industry got pretty much interested in digital transmissions, and RCA came out with a product called Voice Plus. And this was a digital control head which replaced the regular head. You plug the microphone in here. And the fellow who was responsible for designing this product for RCA and getting it on the road is Chan Rapinski. He's supposed to be somewhere here tonight. Where are you, Chan? There he is over there. So I have to be careful. With him in the audience, I have to be careful with what I say. But this was an early attempt at sending pre-programmed messages rather than, you know, sentences after sentence after sentence. There were the popular 10 codes here. There was the thumb wheels that get other 10 codes. There was some popular or common statuses, so that these vehicles, and this is in the era now we're starting to think of transistorization and lower standby drain, and mobile units could be left on all the time, and a dispatcher can now poll the vehicles in the field. And depending upon the way this is set up, he would get an instant message back telling him, you know, verifying the vehicle and the status when last programmed. And there were some union problems with this, of course. There's a situation where, like 2 or 3 o'clock in the morning, the night drive-ins that were open, you might get a handful of policemen in one car drinking coffee and eating hamburgers, and a dispatcher would call, you know, and say each one would be ready to go, and they weren't in their own vehicle. But with this technique, it fooled them. In fact, one of the things we started doing towards the end was also wiring the seatbelt switch in here, so that regardless of what the driver said, it would come back, no driver in the vehicle. Of course, during the years of President Nixon, with all the big grant money that was available to expand communication systems, it was very popular back then to just apply for federal funding for handheld portables. And so these handheld portables really grew by leaps and bounds, because all you had to say is, we're going to provide each policeman with a personal communications, a form of personal communications that we did not now have, and money was easy to come by. This outfit in Florida called Repco came out with a portable built in with a, we call the jerk and run unit. This would mount under the dash of the car, and when it was plugged into the dash, you'd have relatively normal land mobile power, like 25 watts, to be automatically connected to a rooftop antenna, or you could pull it out and run with it as you needed. And this used all modular construction. One of these boxes might be an RF amplifier, a mixer, a crystal oscillator, a discriminator, and so forth. And that made it very simple and easy to service it practically on the spot. The Commission also came out with an authorized vehicular repeater. One problem you have with the use of handheld portables, that you very often the portable can hear the base station for a much greater distance than it can talk back. Am I in anybody's way out there from the screen? Guess not. And so a small little black box was devised that would take the output of a handheld unit that the police officer would take with him when he got out of the car, and his car would act as a repeater, so that he could then talk back to the base station, particularly if he went inside of a building and he was on the fringe area of coverage and so on. And later on, the Commission authorized this for all kinds of service. Paging has come a long way. Paging, as I said, first started out when the first communication systems really were nothing but a very crude form of paging. And of course, if you're in the habit of reading the ads in the airline magazines, we hear all about nationwide paging now and how it really has come of life, and some of these things are pretty small. This particular pager is not very much larger than a cigar. And of course we have alphanumeric, and you can now look at the phone number that somebody wants you to call back and so forth. And radios are getting smaller and smaller. Then CB came about after World War II, and it had a rather unique start. A fellow by the name of Al Gross had built some clandestine radios during the war, and after the end of World War II, he went to the Federal Communications Commission and convinced them that the public really wanted personal communications. And so an allocation was made up around 465 megahertz for a big party line type of radio system. And this is what the early units looked like. There was a dipole antenna at the top, and these were self-excited oscillators, a very simple crude transceiver, which had very limited performance. And the net result was that these two, in many cases, the shipments were only exceeded by the returns. And this was, as I say, was at 465 megahertz. But Al Gross says that he does not want to take credit for what is now the CB radio service. The Commission's answer to that problem was to take the ISM band, which was also allocated to amateur radio, take it away from amateur radio, and give it to Class D citizens radio service. But there are still today many people who are using the citizens radio service to do some good. The big heyday of CB is over, so the 40 channels that we now have, which was 23 originally, aren't all that jammed up. And it's being used in a lot of local communities for neighborhood watch and that sort of thing. And it does work out quite well under many conditions. Al was also involved in paging, and this, by the way, is a new Motorola wristwatch pager, very, very recent vintage. I think Motorola are in partnership, who is it, with Timex on a wristwatch type pager. And all these things are getting smaller and smaller. How many hams do we have in the audience? Oh, I got quite a few. Well, the amateurs lost, and I'm quite an active amateur myself. I came on the air in 1931 on 160 meters, and then when I got my code speed up, I got my license 2 years later. Anyway, the FCC took away 2 megahertz from the 220 megahertz amateur band and allocated it to the land mobile services. And a few weeks ago, they had a filing window open, and the first day they told me something like 100,000 applications filed through the federal lockbox at $35 a piece filing fee, so it doesn't take long to figure out that's $3.5 million. But when I was telling this story to Chan Rapinski, he had that deadpan face of his, and his reaction was, well, what are they going to do for an encore? Anyway, the 220 megahertz band is for narrow band. The channels are only 5 kc wide, and more than likely the first equipment will be ACSB, amplitude companded single sideband. Amplitude companded single sideband is basically single sideband with partially suppressed carrier with relatively heavy modulation compandering, and then sending along a pilot signal which causes the receiver to expand the audio by the same rate that it was compressed going into the transmitter, and as a result you get some favorable signal-to-noise ratios. And it works out very well. You have to send a pilot carrier in order for the receivers to lock onto, because you can't have people, commercial radios, with a tuning dial while they're driving. And probably, no doubt, this will be the first type of, first kind of narrowband radios at 220 megahertz. This ACSB equipment is currently being used on a very limited basis in the 150 megahertz band, interleaved between existing FM channels. Well, here's what the well-dressed two-way radio guy looks like. This is Fred Link, who got into the two-way radio business at the early stage of his life. This car actually belongs to a fellow by the name of Jim West down in Texas, and this picture is once again of the 50s, and so there's one telephone type handset which is used for his own radio system. Another type handset is used on the local sheriff frequency. He's a local, sheriff's auxiliary or something. Another handset is used on this miscellaneous common carrier telephone answering service, and another one is used on the radio, the landline common carrier services. And if I didn't mention it before, back in the late 40s, there were automobiles running around with telephones in them then. Well, throughout the life of land mobile radio, there's been a frequency crunch, and the Land Mobile Communications Council was formed for the purpose of trying to get more spectrum. And the plan that was devised was to share TV channels in certain areas, and the FCC was convinced to put a freeze on further allocation of channels 14 through 20 in the cities of Boston, New York, Philadelphia, Baltimore, Washington, D.C., later on Miami was added, Dallas, Houston, Fort Worth, Chicago, San Francisco, and Los Angeles. And so additional spectrum was created between 470 and 512 megahertz on a shared basis. The Commission came out with another order to maybe relax a little bit on the technical parameters for interference control and to expand to other channels in other cities. But the television industry figured about that time that the American public was entitled to high-definition television, and so any further processing of this idea is on hold. But the real big thing today, of course, is 800 megahertz. 800 megahertz just wasn't grown in a backyard or a garden somewhere. The 800 megahertz land mobile channels were obtained by taking TV channels 70 through 83 away from the TV industry. And one of the first plans was to go to a cellular system. The original concept called for AT&T to have 75 megahertz of spectrum up there and then dole it out. But that was changed because of petitions for reconsideration. And you see these guys reinvented the cellular system from Detroit. And of course the idea is no two adjacent cells are on the same channels. And the plan proposed to the Commission called for cell splitting, so as traffic built up in certain parts, you could break it down to smaller cells. And of course, you're hearing at this conference, the cells could even get smaller than that. And of course, a familiar roadside site you see now, a typical cell site antenna system. The FCC authorized a couple of experimental developmental systems in the cellular radio service, one in Chicago, another in the Washington-Baltimore corridor. And the one in Chicago, which was operated by the wireline carrier, Bell at that time, had 8 sites, and they were limited to, I think, 2,500 mobile units to find out if there was a need for the service. And as the story is told, that even before the system was put together, they had to cut the waiting list off. Too many people were asking for the service. But they were allowed to charge a modest sum, and they had to write detailed reports to go into the Commission's files. And at 800 megahertz, what's known as a picket fence or the standing wave effect is much more severe than it is in the lower frequency bands. At 800 megahertz, roughly you have twice as many nulls and peaks as you have at 400, which is roughly 3 times as many as you have at 150. But the nulls also get deeper. So the first cellular systems use diversity in the mobiles as well as the base station. And at this frequency, it's practical to have 2 antennas on the vehicle far enough apart. So if one antenna is in a null, the other is in a strong field. But with the advent of price competition and so forth, the diversity is only used now at the base stations, although it's still used by some people in the more critical radio services because you can move a car along very slowly with 800 megahertz equipment, and you can find a situation where you can go from perfectly readable signals and over only a few inches of space drop out completely and not even be able to copy the signal. That's when you kind of get out into the fringe area, of course. Diversity, of course, keeps sampling and feeds the receiver with the appropriate signal. And if you're standing still, you can find between 50 and 60 dB of improvement. If you're doing 12 miles an hour, about 4.5, at 55 miles an hour, you can hardly tell the difference. And in some cases back then, they were disconnecting diversity because at certain threshold signals there was some hash introduced, and depended upon how you were using the radio system. This is what a cellular unit looked like some years ago, and you can see the two antenna terminals on here for the two antennas on the vehicle. Of course, the units keep getting smaller and smaller, and this is pretty large even by today's standards now, as cellular keeps going on. The cellular industry now is, is approaching the state where people are saying, are we going to have enough capacity if cellular units keep, building up at this rate? And so through the TIA, the Telecommunications Industry Association, a standard was created for a digital form of modulation that would start out by providing at least 3 times the capacity, voice channel capacity on a given radio frequency channel, and as time goes on, that would increase. Is originally was called a common user system. It's now called the SMR. Some people say SMR as a buzzword. That's Specialized Mobile Radio System. And these are more or less conventional dispatch type channels, but they're trunked. And this gives you, of course, quite a bit additional capacity. If you were to look at the profile of 5 individual channels with no tie-in between them, and look at the dead times, and then you now link them all together so that all units of all 5 channels has access to all 5 units, you can increase your loading. And that's what trunking is all about. Of course, that certainly is done in cellular, but it's also done very heavily in the dispatch radio services now. The dispatch radio service, generally speaking, requires an antenna at a high elevation to give you good coverage. Some people say that maybe that's not effective use of the spectrum, but when you are putting out dispatch calls and polling, you may be addressing as many as 100 units at one time, especially in the taxi cab operation, when you say, is anybody close to 14th and 23rd or something like that. And if you were to do that on a cellular system, and you had 100 cabs with a cellular unit, you'd tie up 100 channels doing that. Well, it just so happens you're not allowed to do it anyway. The Commission, FCC, will not let you do it. And so this happens to be the Empire State Building. So buildings like that, you have now found a new kind of tenant with all these kind of antennas on the roof. This is the 2 World Trade Center buildings downtown New York City, where famous Radio Row used to be on Cortlandt Street many years ago. And some of you fellows out there I know about Radio Row. And here is the installation of the radome on top for, and I didn't take these pictures, by the way, for the final installation. You can see, if you look very close, you can see all of the antennas up here. Now this other thing here is a new TV antenna that was going up, multi-channel TV antenna, which had a lot of legal battles because it was originally predicted that when the World Trade Center building went up, the 2 buildings, there would be serious shadows to TV reception. It wasn't quite that bad, and some people try to back out of this. But they're all up there now and operating from this 90-ton master TV antenna, and that's a story in itself. This logic trunk radio is a system that E.F. Johnson uses, in which subaudible tones are used to do all this controlling, and the mobile units hunt for an open channel and shake hands with the base station, that sort of thing. And you have the same thing in portables now too. And some of these have hundreds of channel capabilities, so when you roam outside your own area, you have access to other systems. The Federal Communications Commission came out with an order, well, it started out as a notice of inquiry and so forth for police to improve their communications. Congress mandated that the FCC come up with a nationwide plan, which has now been promulgated in the 800 megahertz band, and the National Public Safety Planning Advisory Committee has put this all together completely on a nationwide basis now, and over modestly long term, I guess, we'll be able to see where you can reassign a police car from one jurisdiction to the other, and you can talk to the other jurisdiction. What brought this up was the ill-fated Air Florida plane crash over the 14th Street Bridge in Washington, D.C., where many well-meaning people got to the scene, but they couldn't coordinate the activities because they couldn't speak to each other. And here are some of the technical specs that came out to come up with an integrated plan of being able to squeeze channels where the normal spacing is 25 kilohertz between these channels. These are at 12.5 kilohertz with some geographic minimum spacing of base stations. And the fellow on this side here on my right is Tom Stanley, the chief engineer of the FCC, giving a plaque to Joe Nassa of Volusia County, Florida, who is the chairman of this group, who put the plan together. And of course, now we're getting more and more think about data terminals and mobile units. Some of this appliance, especially preventive maintenance type of servicing, is getting to the point where driver leaves the home in the morning with his inventory in his vehicle and gets his first call. He goes there, and then he comes back to his terminal, plugs in the symptoms and the make and model number of the equipment, and he gets an answer back of a most probable problem is in order 1, 2, 3, 4, so forth. And it's also being used by real estate agents and that sort of thing. A company on the West Coast called ETAC has a dead reckoning navigation system where a tape of that particular geographical area is dropped into the unit and synchronized at a starting point, and then the driver has a map in front of him that keeps changing every so many seconds, and his vehicle location is shown here, and as he drives around, the map keeps changing, and of course his reference point physically stays the same, but with respect to the map, it changes. It has all kinds of advantages. Not only that, but when you tie it to an 800 megahertz system now and make use of some of the data capability over these channels, not only does the driver know where he is, but the dispatcher knows where the driver is, regardless of what the driver tells the dispatcher. That's got some union problems too. So these are the kind of things we're getting into now in the two-way industry. In the 800 megahertz band, a company that was formed called Airphone petitioned for some frequencies and got some 800 megahertz frequencies for telephone service from airplanes. And you put your credit card in here and then take a cordless handset back to your seat with you. And some of the newer planes now, newer installations, rather have handsets built into the seat, and you can make your telephone calls from the plane. And now they put this on the Metroliner service between New York and Washington. This system actually talks into the cellular system, whatever cell that the train happens to be going through. NASA has been trying to get Congress to come up with money for other projects, and they at one time proposed to use part of the 800 megahertz band for satellite-aided land mobile communications, and they had one footprint for the entire nation and one by time zones with some offshoots for Alaska, Hawaii, Puerto Rico, and so forth. And of course, satellite-aided communications, is getting to be the thing. Here's an early experiment down, I think it was in Alabama, where using existing facilities, an ambulance service was used to provide continuing communications where it wasn't economically feasible to keep putting up repeater stations and that sort of thing. And this experiment has worked out quite well. Of course, if you haven't heard of CT2, you'll probably, no doubt, will hear about it before this session is over. And of course we're talking beyond CT2 now. CT2 in its basic form allows you to take a cordless telephone and use it in the vicinity of some location out in the public area. Could be a train station, you know, a airport terminal, hotel lobby, and so forth, and talk into the public switch network. But you're hearing a lot about that at this convention. And of course we're also looking at the wireless office, where you can move office desks around with a telephone on them without having to get rewired, except you take the AC plug it out and plug it in another AC outlet. And there are various petitions before the Commission. The Commission has said that sometime this summer they'll be addressing this issue of personal communications from the standpoint of where will the spectrum come from? Who do you have to relocate? You know, who are you going to kick out of what they have now? And try to take some of the microwave frequencies away from the police, for instance. You know, it creates quite a problem. And you know, all of these things these services, even wired communications, is regulated out of Washington, D.C. By the Federal Communications Commission. Those of you who've had the opportunity of addressing a letter, an envelope to the Commission at 1919 M Street Northwest, Washington, D.C., 20554, this is it. And the commissioners sit on the top floor, a few antennas up on the roof, and the common carrier services are in there. And there's a sister building down the street at 2025. This is the laboratory, whose address is Columbia, Maryland, but whose physical location is a few miles outside of Columbia. Here's where all the type acceptance work is done, interference complaints against certain makes and models of equipment is done, and not shown now is a bubble that sometimes is blown up with air to make indoor measurements out of the weather. This is about a 45-minute drive from downtown. In an attempt to cut costs in the more recent years, the Commission moved a lot of its heavy licensing activity, which means, of course, amateur, CB, while it was licensed, business radio, and so forth. The Commission moved to Gettysburg, Pennsylvania, which is approximately an hour and a quarter drive from downtown Washington, just across the Maryland-Pennsylvania border. And this is downtown Gettysburg, Pennsylvania. Here was the first building that was used by the Commission to start licensing. It's an old Buick dealership that was abandoned, and they soon outgrew that, and now they went to larger facilities, and one of these days I'll have a new slide on this. And it's, you know, well equipped now, and all the processors have CRT terminals at their position, and you can call in on the phone now and get a lot of good status reports as long as you know a little bit of information. It helps know the zip code and whose name it's licensed in. But they are giving much better service these days on the telephone, answering questions. Of course, you know, life is not without its problems, but they have a very, very able staff to answer the questions. Now, of course, life has gotten complicated by this guy. Those of you who are in the regulatory loop know about Judge Green and how he's always being asked to come up with another interpretation, particularly in the area, of course, it started out with the breakup of the AT&T empire. And, you know, way back when I first started this show, there was an outfit called RCA, and the federal government got after them because of antitrust accusations, and so they spun off a small company called General Electric. But now, not too much long ago, General Electric bought RCA and merged it into its operation. So there you see it. Anyway, that's my story. Thank you. Any questions? Yeah, George.
Stuart, in the 70s, the early 70s, there was a brave experiment in Chicago that pertained to land mobile and trying to make use of occupancy data in the channels feeding back into the license process.
Yeah.
It sort of came unstuck, but I wondered if you could comment on your view on that.
Well, it was a government project. I think that says a lot right there. I think this is probably described as a situation where the operation was a success, but the patient died. And the problem was that in order to do all of the custom work that was required to make the kind of decisions they wanted to make, you couldn't afford to process the licenses, and this was before the days of fees. And it was an experiment. It was, they gave very good service. People were shocked to get licenses in 2 or 3 days. They were shocked to get phone calls from FCC personnel asking them, here's 3 frequencies, would you like to listen first and pick the best one? But it was probably overkill, and I guess somewhere between what we have now and what we had with that experiment is the ideal. Now, the commission also, as it became more budget-minded, said, gee, you know, the people who benefit from this should pay for it. The taxpayers shouldn't. And so in order to resolve that problem, the commission extended the role of the frequency coordinator, and you know, that was a death knell of the Great Chicago Experiment, which had other names too. But it was just an overkill operation. It was fabulous service, but they couldn't afford to do it nationwide. It worked great on a small selected basis. Yeah.
One other thing that pertained, I think, was the 800 band providing spectrum relief, as distinct from that attempt at trying to get more efficient at using.
Well, yeah, that's right too, because
right in that time.
800 megahertz was kind of slow to grow. As a matter of fact, when 800 megahertz first came out, there of course was a cellular block of channels. There was a court fight that you couldn't give it to a monopoly, and so we wound up with 2 service providers in each geographical area, and that's why your cellular units have an A and a B switch. But there was a block of channels for single channel bread and butter radio systems, and there was a block of channels for trunking, the more advanced state, and there was a reserve block. And it was just slow to take off. And finally, the single channel systems ran out of channels first. They were given some more spectrum. But there's no question about it. What actually happened with 800 megahertz providing a much higher quality service, even with heavier loading, a lot of this other stuff wasn't needed. But of course, with all the things you can do, with all the possibilities of two-way radio, you don't really save spectrum as such. You find more uses for it, and as a result, you create a bigger backlog of demand, and it wasn't very long before 800 megahertz channels in the big cities was selling for, you know, hundreds of thousands of dollars, even though it's technically illegal. It's like the medallion taxi cab in New York City. If you want a medallion, you have to get on a waiting list. On the other hand, if you want to pay $100,000 for a wreck with a medallion screwed onto it, you can go that route too. And that's kind of the route that's gone the FCC thing. Now, some people say this 220 megahertz allocation will give us a breathing spell, some relief. 220 is a good part of the spectrum. The signals cover pretty good distances, and I compared that to like 150 right after World War II. You could go out and buy a 21-foot length of standard galvanized 1¼ iron pipe and put a ground plane antenna on it, and buy a set of TV chimney mounts and strap it to the chimney of a 2-story building, and probably get 25 miles coverage. And that was a pretty cost-effective way of doing things. And to some extent, maybe that will happen at 220. But the big thing on the horizon, of course, is other forms of modulation so you can get greater spectrum efficiency. Cellular is talking short term about 3 times the number of voice channels. The SMR industry is talking about as many as maybe 6 times the number of voice channels by going to time division multiple access modulation. And that's around the corner as far as some equipment showing signs of being available. In the cellular industry, you do have the problem that how do you go from one to the other? And the way you go from one to the other is you have dual mode equipment. And so that standard I had on the screen was entitled a dual mode standard. And Now, not only do we have time division multiple access coming along, but some people think maybe sped spectrum is the way to go, and some people think maybe there are other ways. So the thinking now is that as long as you have dual mode equipment, and that second mode is always what we have now, you can provide the interoperability and the transition. Now, the Commission did something in recent years with the cellular type of license. In giving the cellular additional spectrum, I might back up a step, the idea of cell splitting, of just putting in more cells as the traffic demands, looks good on paper, but there are some problems with that, especially at the price of real estate in some places. And even at that, maybe if you're in a big city, you can't get good locations to get cells small enough to give you omnidirectional coverage or circular coverage. So the cellular argument went something like that: we need more spectrum right now to continue to grow because we can't carry cell splitting any further. It's just not economically feasible. So what the Commission did in coming out with a report in order is say, we're giving you this extra spectrum, but keep in mind it's the last time to dip in the barrel. You better find better ways of doing things. It said, to the cellular provider, the service provider, you no longer have to provide nationwide interoperable service on all your channels. So, and you decide what you want to do, but theoretically you have two carriers, two service providers in each area. Competition will take care of lousy service. So, and this is the way it's going now. What will probably happen is a certain number of exotic unit B will be used on some of these newer channels, and as that demand keeps growing, more and more of those will be spreading into the older channels as equipment is changed out, and you're going to have dual mode. Some people say there'll always be parts of the country where the present system will go for years and years, and maybe you can ship the older units into them. And so we're about to see a shakeout era take place. But that's the route that's going, not only for cellular, but plain bread and butter dispatch operation. And this 220 megahertz using the 5 kc discrete channels is going to be in competition with the other systems of modulation to really find out what's the best way to go. When you have these individual 5 kc channels, you can pretty well locate each 5 kc segment. But when you take a 30 kc channel like you have in cellular, or 25 kc in traditional two-way, and chop it up into bits, those bits per channel have to stay together, and you don't have the same flexibility in redesigning your system to take care of individual requirements. And so, on that standpoint, one will be in competition with the other to prove where our future will be. Yeah?
What roles have other countries played in the history of mobile communications?
Well, I could, first of all, a heck of a lot. And of course, in recent years, very much so. Where most of the stuff comes from in this country, it comes from across the Pacific. The British have had many pioneering efforts in improved spectrum efficiency. They have used 12.5 kc channels over there long before we have. They have cut the power down. They have limited power. We're power crazy here. In the bread and butter bands, our maximum mobile power is like 110 watts today. But how often do you need a 100-watt mobile transmitter? Canada, the CN Tower, the Canadian National Tower, which is a very good base station site, they have very severely limited power to several watts. You can't go on the air with these blockbusters. So they have played, I would say, probably a better role in frequency coordination, not only as far as normal selectivity or bandwidth of a system, but also geographical selectivity and not allowing too many base stations to cluster close to each other on very close channels. We have made some attempts in this country. There's no question but what a lot of equipment has been coming into the United States over the years and has had a lot of technical breakthroughs. I would say we probably tend to offer more in the way of quantity, with quality of course, but I think in this country we have been able to prove and disprove high density systems either will or won't work. When when trunking first went into operation in Chicago, a frequency plan was used where the channels in a given system were one alongside the other, and all of a sudden we got a call from the private radio bureau, had a different name back then, that we're having intermodulation problems that won't work. So then the Electronics Industry Association and its member companies got together and came out with a plan of separating each channel of a given block by, say, a megacycle. And then you overlaid one over the other. And you just played a numbers game, you know, to suit it. And as a result, when you go through the latest rules today, there's an early Chicago plan and then a late plan, and of course there's the rest of the nation. But the first trunking system in the non-cellular systems went on the air in Chicago, and that problem became known almost immediate.